Hello everyone. If you want to install a solar home system and if you want to make the decision of the component selection by your own, this video is only for you. So stay tuned. Okay, first of all you have to know about a solar home system. Actually it's a combination of some electric components you see here. Okay, let me show you a diagram. In this diagram you can see they are the DC loads and it's a AC load. So if you want to run this AC load, you have to purchase an inverter. But you can feed those DC loads directly by the solar module. Again, if you want to ensure the continuous flow of energy, you have to purchase a battery. Again, to regulate the battery life, you have to purchase a charge controller. Actually, the charge controller will regulate the overcharging and undercharging condition of this battery. Again, to distribute this power between these loads, you have to purchase a junction box. So, these are the components you will need. So you have to make selection of all these components. Selection of location will be a very important part. First of all, your solar panel should be exposed to the sun directly facing north in the southern hemisphere and south in the northern hemisphere. It will maintain a optimum tilt angle of 25 to 30 degrees. What is a tilt angle? A tilt angle is this angle. This angle is called a tilt angle and it will be 25 to 30 degrees. Again, you have to maintain the shortest distance from the home. Okay, the shortest distance will provide you with the minimum heat loss. So selection of the panel location is very easy part. Now we will talk about the most important part, the selection of panel. To select a perfect panel, you have to make an energy audit to know the requirement of energy in your home. You can do it in two ways. In the first way, you will need a component named kilowatt. It will give the power used in your house in watt hours. If you don't have a kilowatt, then you can use this formula to calculate the required power in your house. Here I took television as an example, and here E is the energy consumption by the load, P is the power rating of the load, and H is the daily operation time of the load. Now using this E, you have to calculate this IM. Now what is this IM? It's the current generated by solar module. Actually, before using this E, you have to multiply this E value by 1.25 because there is loss and you want to produce more than you required. Now what is HP? HP is the peak sun hours. It's generally around 4 hours, but you can Google it by your location and it will give you the value of peak sun hours at your location. And BV is the battery voltage. It's generally 12 volt for a lead acid battery, which is a deep cycle battery. After getting the IM value, you have to get a solar module catalog. Then you have to match the calculated IM value in the catalog at peak power. Then you have to pick a panel having equal or greater value than the calculated IM value. consider how many panels do you need. If you consume 7.5 kilowatt per day and your selected panels have 400 watt rated power, then just divide 7.5 kilowatt by this 400 watt. Then you will get this value 18.75. That is almost 19. Now you have to select the battery. Actually, the battery is the most expensive part of the solar home system, and you have to select it carefully. You can use this equation, where E means the energy used by your loads and DOD means the depth of discharge. For a lead acid battery, it is around 50%. BP means the battery voltage, which is 12 volt around, and NA means the autonomy days, which means the number of days a battery can serve you without being fed by the solar panel. So we know all these values, and we can get the battery capacity from here. It's in ampere hour. So after we have determined the battery capacity, we can get it from the market. But you have to remember this equation, because battery capacity can be given in kilowatt hour or in ampere hour. So you have to calculate the ampere hour capacity in kilowatt hour. Now if we consider the 7.5 kilowatt daily use as we saw before, and if we consider 2 autonomy days and 50% of DOD, the battery capacity will be this or this. You should always remember this voltage is always can be converted by this equation. So you will round this number and get the immediate next available battery in the market. Selection of the charge controller is the most tricky part. Actually, you can use this formula. IL max is the maximum battery to load current in ampere, and PT means the total power. Remember, PT means the total power, not total energy required by your load. That means you don't have to consider the daily uses hour. So you have to sum up all the rated power you have in your home, and BV is the battery voltage, that is 12 volt. So we can get IL max easily. Then we have to follow two steps. First of all, you have to multiply the battery to load current by 2 for getting the best charge controller, and the voltage rating of the charge controller will be the same as the operating voltage of your solar home system. So you can get your charge controller in the market by this rating. Okay, now inverter will be needed to use the AC loads. So you can use this equation for selecting an inverter, where P load means the load in watt for the AC loads. You have to consider only AC loads here. And remember again, this is not in watt hour, so you don't have to consider the daily use hour of your AC loads. And PF means the load power factor, that's around 0.8, and efficiency will be around 0.8 we will consider. So you will get the power rating of inverter, which is in volt ampere. Now if you consider a 21-inch color television whose rated power is 50 watt and which is to be operated in 220 volt AC supply, then the inverter will give you this 78 volt ampere value. But whichever value you will have, you have to multiply it by 2.5 for having the required capacity of the inverter. So you have to multiply it by 2.5. You may have need some DC to DC converter because some of your small loads will operate at 3 volt or 4 volt say, and you have to see this rating of the small loads and go to market and say about it, then you will have your DC to DC converter. Now we will talk about the selection of switch. For DC loads, switch can be two types. You can use 2 ampere DC or 5 ampere AC. Both will be applicable. But for AC loads like TV, 15 ampere AC switch will be required. And for the other AC loads, for higher loads, Googling will help you for selecting the switch. Now talk about the wire selection. You have to calculate the minimum diameter of the wire required. Now you can use this equation for getting the cross-sectional area of wire, where L is the length of wire joining solar module and charge controller, which is in meter, and Im is the current flowing from solar module to charge controller, which is in ampere, and delta V is the voltage drop. We will consider 5% voltage drop here, and so you will have the cross-sectional area of wire. Now you have to calculate the diameter. You can use this formula using the cross-sectional area pi. So you have the diameter here in millimeter. So this is the minimum diameter you will need, but you will go for multi-strand thick wire because the higher the diameter will be, the less the heat loss will be. So thank you for your time. Hope you understood this concept of selecting your solar home system. If you have any question, then put a comment in our comment section. I will answer that. And if you have any requirement for any of the topic in this video, you can also comment it. I will cover it in my next video. So thank you. Take care.